Good morning, viewer. Bien here. Here's the breaking news. Yes, an international team of researchers led by the University of Potsdam has generated and analyzed the first high-coverage nuclear genome of the extinct blue antelope in cooperation with Colossal Biosciences and Museum of National History, Berlin. This genomic information provides insights into the evolutionary trajectory and the reasons behind the extinction of this species. The blue antelope holds the distinction of being the only large African mammal to have gone extinct in recent history. The result of the study, which have now been published in Current Biology, show that the species was probably adapted to a small population size and survived like this for thousands of years. However, this also made them susceptible to sudden impacts like hunting, which increased after European colonization of southern Africa. Yeah, the blue antelope, Hippotaragus leucophaeus, the scientific name, was an African antelope with a bluish grey pelt related to the sable and the roan antelope. The last blue antelope was shot around 1800, just 34 years after it was first described scientifically. The research team, which included postdoc evolutionary biologist led by Professor Dr. Michael Hobrettier, has now succeeded in obtaining a 40-fold high coverage genome from a specimen at the Swedish Museum of National and also the Natural History. This is one of only 5 DNA validated historical museum specimens of the blue antelope. Long genomic diversity and population size is often considered a disadvantage, as they can lead in a reduction in the fitness and adaptability of a species. However, the blue antelope had a small population size for many millennia before it became extinct around 18,000. Michael Hobrettier explained the fact that no inbreeding and only a few detrimental mutations were detected indicates that the species was adapted a long-term low population size. Low population size, adds Elizabeth Hampel, who studied the blue antelope as part of her doctoral thesis at the University of Potsdam and the Museum Natural History, Berlin. The analysis of the long-term population size also shows that it was not influenced by ice age climate fluctuation. This is unexpected for a large herbivorous mammal, as these cycles should have led to changes in habitat availability. This result suggests that current models of long-term ecosystems dynamics in the region may need to be refined. The researchers concluded from their result that species can survive for a long time with a small population size as long as they are not exposed to fast-acting disturbances. Consequently, the sudden human influence during European colonization of southern Africa in the 17th century likely played a central role in the extinction of the species. In the course of the DNA analysis, 2 genes were also identified in the genome that could be responsible for the species blue pelt color to which the blue antelope owes its name. This was made possible with the help of state-of-the-art computational analysis software from the biotechnology company Colossal Biosciences, with which the researchers collaborated as part of Colossal's ongoing focus on ancient DNA. Yeah, genotype to phenotype relationships and ecosystems restoration. We were honored to collaborate on the groundbreaking work of Professor Hobrettier and his team, said Ben Lamb, co-founder and CEO of Colossal Bioscience. The research objectives for the project allowed our teams to work together, applying some of the latest colossal ancient DNA and comparative genomic algorithms to learn what truly made the blue antelope the unique species it was. Be this exclusive report.